Hello friends, Eli Hibbett here with the Pwn Your Homework Physics Series podcast. If you're looking to prepare, review, or gain an added edge or point of view about topics in physics, then look no further. Tune in each week to unlock your understanding of the physical world surrounding us. And now let's dive right in. Alright, how is everybody feeling today? I'm Eli Hibbett, your host, and welcome to this week's edition of the Pwn Your Homework Physics Series podcast. Today's episode is entitled Vectors and Scalars, episode 13. So yeah, I hope you're doing well. I hope your physics journey is getting more and more enriched as the days go by, and that you're staying in the zone with the help of this podcast. So after our Halloween episode, I think we're going to get back into a more typical format with, topic-based little trinkets and nuggets that are going to help you get into the zone. One thing I wanted to mention is that I put up a new post on the website. It's not a episode post. It's just pwnyourhw.blogspot.com, pwnyourhw. And it's a kind of an interesting mathematical idea about drilling a square hole and the shape that the bit needs to take in order to drill a hole that's in the shape of a square. And the solution actually looks something like a triangle. It's kind of triangular, like with rounded edges. And there's a little video that has no sound. It's in Russian, allegedly, and it shows this thing in motion and how it cuts a square hole with like a round drill bit. So if you're into that sort of stuff, if you're into math and geometry, I highly recommend it. And so get down. Next up, our musical clip of the week is not an actual song in a traditional sense, but it is some bed music to a old Sega Genesis game called Vector Man, which I thought was a very fitting musical clip for this episode, Vectors and Scalars. And so what I wanted to read you the Vector Man synopsis from the Wikipedia entry on it, give you kind of a taste of what we used to play way back when. In 2049, the human population of Earth embarks on a migratory voyage to try and colonize other planets. They leave mechanical Orbots to clean up the mess they made on Earth through littering and pollution. Raster, a high-level Orbot who watches Earth through a planet-wide computer network, is accidentally attached to a working nuclear missile by a lesser Orbot and goes insane, becoming an evil dictator named Warhead. He declares himself ruler of Earth and begins preparing to execute any humans who dare to return to their planet. Enter Vector Man, a humble Orbot in charge of cleaning up toxic sludge by simply discharging it into the sun. As he lands on Earth after his last trip, he finds chaos and confusion, because all of the other Orbots are controlled by Warhead. Vector Man has not been affected because he was away. Vector Man takes it upon himself to destroy the errant Orbot and restore peace to Earth. I mean, to me, it sounds like a little more aggressive version of WALL-E, kind of. What a kind of vague synopsis. I mean, what does that have to do with vectors? Why is he called Vector Man? And it's just kind of like a level run-through point-and-shoot type of game. Really fun, but yeah. Anyway, Vector Man. So that is the synopsis, and I'm going to play for you a little clip from the original score, if you will, to Vector Man, the original soundtrack. Here we go, musical clip of the week. All right, that's enough. Let's get back into it here. But man, what a flashback down memory lane, Vector Man. So, with that, let's get into the quote of the week, which is coming from Richard Feynman, and he says, "The first principle is that you must not fool yourself, and you are the easiest person to fool." And the reason that I picked that for this week is, with vectors and scalars, some people don't have a necessarily innate understanding or like a natural feel for the difference between a vector and a scalar, and I think that you should really, if you understand the underlying concept, don't try to trick yourself into thinking, okay, this is a vector. Someone tells you, this is a vector. Don't just say, okay, I understand. Try to really grasp it for yourself, because if you just fool yourself into thinking you understand, it's going to come back and it's going to be an even bigger problem later. So use that advice free of charge. So, what is a vector and what is a scalar? I think I can break it down very easily. It's very simple. A vector is something that has magnitude and direction, and a scalar only has magnitude. If there's a plus or minus sign, this is a direction. If there's a direction, this is a direction. If someone says you're going north, that's a direction. If you're saying you're going on the positive x-axis, that's a direction. If it says you're going 25 degrees with respect to the positive x-axis, that's a direction. Those things are called vectors. They say you're pushing with this much force in this direction. Just saying how much force you're pushing is not a vector quantity. And so if you have both those things, how much and which way, you have a vector. Everything else is a scalar or a constant. So I have a little example here. If you have, let's say, a car driving down the road at 25 miles per hour, is this a vector? I would say no, because you don't know what direction the road is traveling. I mean, if you happen to know that embedded in the problem somehow, you can say it's a vector. But if you don't know what direction the car is driving, this is what's known as speed. Speed is a scalar quantity. It is how fast the car is going, but you don't know which direction. If the sentence were to say the car is traveling 25 miles an hour to the north, you say yes, I know that this is a vector quantity. And if you know how fast it's going and in which direction, this is what's known as velocity. So this notion of motion and how fast you're going, there's a vector and a scalar version. And so vector is velocity, which is easy to remember, and scalar is speed, also easy to remember. You have the V's and the S's. And I think this is the easiest analogy. When you're doing different problems and you're trying to figure out whether something is a vector or a scalar, just kind of try to draw that analogy into a car traveling in a direction. Either you know the velocity or the speed. And I think that you really can't go too far off base by doing that. So, the reason that vectors and scalars are important is because the rules for doing math with scalars and scalars, vectors and vectors, and scalars and vectors are all different. So you have to know what type of quantities you are dealing with. And we are going to dedicate an entire episode to this in the next couple of weeks. So that's kind of the reason why you need to know what something is a vector or a scalar. I don't know if you have listened to scientific talk a lot, but you'll hear people asking, oh, is it a vector or a scalar? And you're like, who cares? What's the difference? Why does it matter? And this is why. Because how you operate these things together mathematically is very important. One other thing I wanted to mention, I guess tying in with our Halloween episode last week about dimensions, is that this direction that something is going can span across several different dimensions. It's not always just, north. You could say east of north, northwest. Something could be traveling, up in the air as well as north. So you can spread it out across all different dimensions. And this is kind of where the vector thing takes into account. Because if you have a direction, you can actually break it up into different dimensions, and that's how you kind of work with it mathematically. More on this soon. Stay tuned. So right now I'm just going to rattle off some examples of scalars. Angle, density, distance, frequency, kinetic energy, length, magnetic flux, mass, potential energy, power, speed again, time, voltage, and work. And so all of these things are just a magnitude. They're just a value. They don't have a direction associated with them. And so now I'm going to rattle off some examples of vectors. Acceleration, angular momentum, displacement, electric field strength, force, moment of inertia, momentum, position, tension, force again, velocity, and weight. Now, these are not all the vectors and all the scalars, but they are it's sort of a comprehensive list of things that you're going to see right off the bat. One thing I wanted to mention is that that list of vectors I just went through, when you think about any of those quantities, you can usually think, when you talk about a force, there's always a reference point. This is kind of a telltale sign of a vector. So when you say that you're pushing with a force, you know that you are pushing in a direction. You can always tell, I'm pushing in a direction. Tension, when you're pulling, where are you pulling? You're pulling up, you're pulling down, you're pulling to the side. One other thing, I mentioned displacement being a vector quantity and length being a scalar quantity. And so if you know that you have traveled, let's say 4 feet to the left, that's a displacement. We don't call that a length or a distance. And if you say you just move 4 feet, then we call that a distance. So that's kind of the difference, the vector and the scalar versions of that. So what I mentioned before about the reason that you want to know this is because of how it affects the math. How do we tell the difference between a vector and a scalar in an equation? How do you know if this quantity is a vector quantity or a scalar quantity? Well, one of the most common ways to do that is vectors usually have an arrow above them. And this is actually painstakingly, exhaustively descriptive. It's saying that this thing has a direction. And usually it kind of looks like a fishhook almost. It only has the top half of the arrow, but sometimes they put the whole arrow. Other times I've seen in text that vectors are bold. Scalars are usually like a plain text, kind of treated like constants because they don't have that accessory, that extra descriptive with them. So vectors are usually denoted in some other way. So when you see bold text or you see the arrow above it, you know that that's a vector, and that means you have to do a different type of math because there's a little more there than just a constant. So that is vectors and scalars. I mean, there's not that much more to it. I think that, it's kind of an intimidating topic to begin with, but when you really boil it down, that's it. So if you want to review this a little more, I have an app for the iPhone, Exploring Physics, Vectors versus Scalars. And in that app, I go through those vector and scalar lists that we went through. I also have a tap review, which I kind of like to call like a graffiti on the wall style review. It actually has just a whole bunch of vectors and scalars kind of strewn throughout the screen, and you can tap each one to see whether or not it's a vector or a scalar. And I have 2 different walls since there were so many of them I couldn't fit them onto one screen. And then I also have a flashcard style review where you can go through each one and test your strength, test your knowledge of whether or not you know the difference between vectors and scalars. And I think there's a lot of room for growth on that app. If there's any vectors or scalars that you'd like to see and you have the app, you can hit the participate button inside and let me know what you think. But the app is 99 cents in the App Store. And for the listeners to this podcast, I wanted to throw out a little offer. If you want this app for free, I'm offering out 5 free download codes. So if you want to tweet me at 2718 Productions with a hashtag Vec versus Scalar or hashtag pwnyourhw, I will tweet you back with the download code. And if you don't have Twitter, if you hate Twitter, if you just want to leave a comment on pwnyourhw, pwnyourhw.blogspot.com, I will hit you that way. So if you're into it, you want to review further, and you want a free app if you have an iPhone, hit me up. Outside of that, I think that's going to do it for this week. So stay frosty, stay into it, stay in the zone, and I'll catch you on the flip side, guys. Take care.